Good morning, guys. Today we have a practice problem from Chapter 2, Motion in One Dimension. Now this is a challenging problem, but we can go through with it. So let's start by reading the question. Starting from rest, a police motorcycle is capable of achieving a constant acceleration of 6 meters per second until it reaches a maximum speed of 55 meters per second. Question A asks, at what time, Tmax, and coordinate, Xmax, does the motorcycle reach its maximum speed? Alright, well, as always, the first thing that I like to do is always to list the many known variables that we have. So, we know that it's starting from rest, so we have x is equal to 0 meters. We're looking for the maximum coordinate, for which basically like the furthest, they're just the coordinate at which the motorcycle will reach its maximum speed. So we don't exactly know this. We also know that because it's starting from rest, of course, 0 meters per second is the initial velocity of the motorcycle. The final velocity is the maximum speed, which is 55 meters per second. We know that the acceleration is 6 meters per second squared, and we also don't know what the time is, right? So there's two things that we're looking for. We're looking for this, the max coordinate, max x coordinate, and the max time. So, looking at this, you might be a little bit like, what do I do next? Well, what I like to do is go into my notebook and check, well, in case I haven't memorized these equations already, and check which kinematic equation excludes, which kinematic equation either excludes t or x of f. And we have two equations, like one that excludes one of these, the other that excludes the other, meaning each equation we'll be able to solve for it. We'll only have one unknown variable in each situation, and we can solve, giving us the values that we want. So for the final position, we'll use the final velocity is equal to the initial velocity plus 2a x final minus x initial. So, what can we do here? We can just input the values that we do know. We know that that's 12. The initial is 0, so we can just input x of f here. And when you solve for this, you get 55 divided by 12, which is 252 is equal to 252.08333, and so on. I can just write periodic. I'll keep that. I'll make sure to write a couple extra 3's when I'm calculating on my calculator. The next thing that we're trying to find is the time at which that happens. So now that we do not need to find, we're trying to find the equation. Now at this point, we're trying to find the equation that does not have x of f. And that would be v final is equal to at plus vi. And so this is a very simple solve. 6 times t, so we have 55 divided by 6, which is 9 t is equal to 9, and this is meters, 9.16 periodic seconds. Okay, well great, we have our two values. Now we're going to move on to question B, but we're going to make sure to write down those two answers somewhere. I can wipe this out. And make sure to keep these somewhere. We'll keep them in our back pocket over here. We'll call this one X max to not confuse ourselves. 252.0 0.083 periodic, and T max 9.16 seconds. There's a periodic on that. All right, question B. This is a multi-part question. It's a part of the reason that it's so difficult. What is the motorcycle's position at t is equal to 15 seconds? And so let's think about this before we go straight into answering. Since we already have all of our values, we could easily just input the known variables of the situation into any equation that has final position, and then try and find it. But try and find the answer. However, there is a small, important part to this question that we have to acknowledge. So let's actually graph what the velocity of this motorcycle is. The velocity versus time. So we start at, okay, so the velocity is initially 0 at time equals 0. Then it increases at a rate of 6 meters per second, right? Until it reaches 55 meters per second. I can just write 55 here. 55 at 9.16 periodic seconds. Right, I can remove seconds actually. And at that point, the speed breaks even, and it just like maintains itself. It's a maximum speed, and the police officer wants to go as fast as possible, right? So, when we look at this, we have a hint at a mistake that we might make. At 9.16 seconds, the motorcycle stops accelerating. Thus, the distance that it was covering here, which is actually the integral over here, the distance it was covering is now no longer, the distance that it was covering up until 9.16 is not applicable after. What I mean by that is we're first going to have to, we have to basically start counting after 9.16. Yeah. So what we're going to do is just, so basically after 9.16 seconds, we have a constant velocity of 55 meters per second. So constant velocity of 55 meters per second. And this, if you recall from one of my previous videos, this is actually the second easiest type of question, right? So it's a constant velocity question, meaning there's no acceleration. So we can just use this equation to solve we do 15 minus 9.167 is about equal to 320.8. Okay, so we have our final position, right? But we do need to consider one extra thing. This is the final position for just 9.16 until 15 seconds. But what about before this distance? We also have to include it in our answer. So we're gonna write x of 15 is about equal to the sum of both. which I've calculated out to be 572.898 meters. Yeah, and that's pretty much it. This is a pretty simple problem still. It's just a tricky mistake, a very easy mistake to make. And now we're going to move on to part C, and this part usually takes people by surprise. So we're going to keep that over here. 15 is about equal to 572. This is about, actually, whatever, we'll keep it there. Gonna erase question B and write our question C. I'm gonna write a little small because we have a lot to write. The police motorcycle is waiting at a speed trap. A speeding car drives by at a constant speed of 40 meters per second. It's quite fast. The police motorcycle begins pursuit accelerating at 6 meters per second squared as before. How long until the motorcycle catches up with the car? Quite a long question. They're giving extra context. The police motorcycle is waiting at a speed trap at a speed trap. A speeding car drives by at a constant speed of 40 meters per second. The motorcycle begins pursuit, accelerating at 60 meters per second squared as before. How long until the motorcycle catches up with the car? Well, at this point, this is actually a very odd question to answer. Like, there aren't a lot of questions like this, but we need to start somewhere. What is the question really asking? How long until the motorcycle catches up with the car? So basically, the question's asking, when is the X of police, the position of the police, going to be equal with the position of the speeder, right? And that's a big hint at what we have to be doing. Now, the first thing that we need to consider, though, is that the police's speed is fluctuating. It changes from at least between 0 and 9.16 seconds. So we have to start by splitting up this question into two parts. In stage 1, we have to determine how. We know that the police car has traveled, so in 9.666, actually let's just put periodic. We know that in we know that the police car has traveled about 252.08 3 meters in 9.16 seconds. And for the speeder, we know that what we can do is actually calculate how far he's gone. The way that we calculate this is just multiplying his speed times the time that it takes him, the time in which we're trying to see like how far he goes. So 9.66666666 times 40, which gives us 366.667 meters. All right, so in stage 1, we can clearly see that the speeder is ahead of the police, right? And now from this point on though, the police car will be traveling at 55 meters per second, and the speeder will be traveling at 40 meters per second. Judging by this gap in speed, we know that the police will eventually catch up to them. The question is when, right? So we're trying to find out when these two cars will catch up to each other. So we're gonna have to use an equation that has both t and that uses final distance, right? Because we're going to want to make sure that those ones are equal. So it's the final distance, the final position, not distance, I'm sorry. We want to make sure that the final position on both of those are the same, right? So we know the initial and final speeds of both. So what we can do is actually calculate with this equation. XF is equal to 1/2 times VI plus VF T plus X plus X1. So the major thing that we have to acknowledge though is that V1 and VF are the same thing for each individual car, and we're going to be using two of these equations. We know that this is common ground for both equations, so we're just going to set those equal to each other. We're going to have, and if we set those equal to each other, we're going to have this, the speeder times T plus XI speeder is equal to 1/2 times V of police times T plus the XI. I'm just going to erase that for the sake of space to make sure that you guys can see. V of police times T plus XI police, right? We set those equal to each other, and now we can actually multiply both sides by 2, and we get rid of fractions. Next, we just enter our numbers in, and when we do that, we get this one. Oh, actually, one important other fact is that the time actually, we can do that later. I'm sorry. Okay. Like that. T. Okay. So when we plug in our numbers, let's see what we are going to get. So the police's speed is larger, so we're going to take the speeder's speed and subtract it on both sides. And his speed was 40, the police's speed was 55, so we're going to end up with 15, basically 15 T, which is equal to, and then we're going to take the police's XI and subtract it on both sides. So 366.66666 minus 252.0 83, which is equal to 114.58366, right? And then we're going to divide that by 15. And we get 7.6389111107 seconds. And this might seem like the end of the problem. Someone might say that that's how long it takes, but that is not correct. This is without including the time that it took to just the time that it took to get to the second stage, which I forgot to write here. The first stage lasted 9.16 seconds, and the second stage lasted 7.6389 seconds. But when we add them together is when we finally end up with the result we're looking for, which is T final is equal to 16. I'm just going to write about. It's about equal to 16.8055.7111 seconds. A lot of decimals, but that's your final answer. It took a long time. So the real trouble with this question was splitting it up into stage 1 and stage 2, since the accelerations of the two different vehicles were different, so we needed to consider them individually. And that's pretty much it. Thank you guys so much for watching. I hope you were able to solve it on your own, and I'll see you in the next video.